The charges Q1 and Q2 lie on the x-axis. The first charge is at the origin and the second at 1 meter. Determine the equilibrium position for a third charge, Q3, with respect to Q1 and Q2 for each of the following cases. The first one, which is the one that I will do, it says that I have a charge of Q1 of 10 microcoulombs and Q2 of 7.5 microcoulombs. So in the first place, all I have to do is I need to do a sketch. Okay, I need to sketch the situation. So that's exactly what I'm going to do in this moment. The sketch helps me to visualize better what is going on in the problem. So it says that I have two positive charges, okay, and also they lie on the x-axis, okay, like this. So I will place my origin right here, okay, and my charge of 1 meter I will put it here, okay. It says the first charge, which is Q1, lies on the origin, okay. So in this place I'm going to place my Q1. It's a positive charge. And I leave it there. And also the other charge is a positive charge too. Okay. Now the problem is asking me in which place I need to locate a force, a charge Q3, and it's going to be between Q1 and Q2, okay? Because if I want to find the equilibrium position, it must be located in this area, okay? Now, I don't know where exactly. I'm just going to put a circle over there. I'll do a few changes here. Okay, better. And I will put my, I don't know, Q3, I will put it here. Remember, I don't know the distance. That's what I'm looking for. That's what I'm looking for, and this is going to be my negative charge. Okay, so this is going to be Q1, this is going to be Q2, and this is going to be Q3. This one measures 10 microcoulombs. This one measures 7.5 microcoulombs. And this one is not given, but I don't need it. I don't need to know it because the forces that I use, I mean, the charges that I use to get my forces are 10 and 7.5. I don't need to know this one, okay? So the data is fine. And what I do after is I'll use algebra to establish the distances between the charges. For example, I know that all this distance is 1 meter. Okay? And because I don't know which distance is this, I'm gonna call it B. So how is gonna be called this portion? How can I call this portion here? In terms of D, okay?
B minus 1.
No, close but different. I'm gonna put another example here as a practice, okay? Get used to work like this in this topic. So take a look to this. Take a look to this. I know that this distance is 7 meters, okay? For example, I know that this distance is 3 meters. And if I ask you, guys, what operation do we need to do to find this distance? What operation do we need to do to perform to get this distance? Okay, how do I get it? If this
7 minus 3.
7 minus 3, okay? If all this is 7 and all this portion is 3, then this part right here is going to be the difference. And the difference is just a subtraction. From the whole 7 meters, you will take away this little portion of 3 meters. So in total, this will give you 4 meters. And as you can see, it makes sense. So let's apply the same principle here in this little portion above. How do we get that part? How do we get that part?
1 minus B.
1 minus d. It is different than saying d minus 1. Okay? So from the whole 1 distance, we're going just to take this little portion away. So it is 1 minus d. Okay? And to find the equilibrium position, we say that the forces, the electric forces, by using Coulomb's law, both need to be the same. They need to be equalized. So take a look. Okay, there I have Q3. Okay. Now, what kind of force is going to be between Q3 and Q2? Attraction or repulsion?
Attraction.
Attraction. So that means that my forces are gonna come like this. Okay, they want to be like together, like that. So my My force comes in this direction. And I will call this force 3, 2, because it is between 3 and 2. Okay, between Q3 and Q2. Now, what kind of force is going to be exerted between Q1 and Q3? Attraction or repulsion?
Attraction.
Attraction. So I know that for my forces to be cancelled, I need them to be the exact same force. Okay, that's why the two forces, as you can see, they measure the same, just to indicate that they are the same. Okay, so this force, it is between my Q1 and my Q3, so I'm gonna call it force 3, 1. Okay. Now, what is the distance that I have between 3, 1? What is my distance? Okay, between Q3 and Q1, what is my distance?
We don't know.
We don't know it, okay? All we know is that we call it D, okay? So I need to know what is this distance. I don't know it, okay? But we already defined in the beginning of the problem that we are going to call it with the letter D. So R31 is going to be D. What is the distance between 3 and 2? The distance between 3 and 2 is this one. How do we call that distance? We don't have a value.
1 minus D.
1 minus D. Okay? And with this, you have all the data available to get the equilibrium position. So first, we start by equalizing the two forces. We say that the force 3, 1 is equal to the force 3, 2. We write the definition of force as by using Coulomb's law, that is Kc times, in this case, is going to be Q3 times Q1 divided by the distance 3, 1 raised to the second power. And in the other side, we are going to have force 3, 2, that is Kc times Q3 times Q2 divided by the distance 3, 2 to the second power. That is the definition of the two forces. And what happens now is that we start canceling what is repeated in the two sides. What is repeated in the two sides?
Kc.
Kc is repeated, so it's going to be cancelled. What else is repeated?
Q3.
Q3 is repeated. So we also cancel it. And then you can see that the equation is being simplified a little bit. So you have q1 divided by r31 to the second power equals to q2 divided by the distance 32 raised to the second power. Now that I have all this, I'm going to leave my r's in one side and my q's in the other side. So to do that, I need to make a cross multiplication. Okay, I need to send this one that is dividing, I will send it to the other side to multiply. The q1 that is above, that means that it's multiplying, it's going to be sent down to divide. Okay, so I'm gonna have r 3,2 raised to the second power divided by r 3,1 to the second power equals q2 divided by q1. Now I will substitute by the givens. So r32 is this value here, okay, is 1 minus d raised to the second power divided by, now this value over there, 3,1, that is d, raised to the second power. All this is equal to q2. q2, it is given as 7.5 microcoulombs. You know that the prefix micro means times 10 to the negative 6 coulombs, and q1 is 10 microcoulombs, so it is 10 times 10 to the negative 6 coulombs. Now, take a look to this part. This is the scientific notation part. The two are the exact same. Both are times 10 to the 6th power. And because they are being divided, they can be cancelled. Okay? Imagine that you are dividing x squared divided by x squared. How much is this? This is cancelled, right? You cancel it. But you cancel it for no reason. I mean, the reason why you do it is it has a purpose. In math, when we have exponents and we divide exponents, we subtract them. We copy the base and we subtract the exponents. So this is equal to x to the 0, and then we apply the properties of exponent 0, that says that every number raised to the 0th power is going to give you 1. And 1, when you multiply times 1 or you do whatever thing times 1, it can be totally invisible. So that's why we say that x to a 10 to a negative 6 and 10 to a negative 6 can be cancelled. Okay, so just leave the numbers. That will be okay. Now, how much is 7.5 divided by 10?
.75.
Okay, so we are basically just working with this number, with this fraction. So this is 7.5 divided by 10. So we continue. This is equal to 0.75. Now, so far the process has been very nice, and what we need to do now is we need to apply properties, we need to get rid of this power of 2, okay? And to get rid of it, I need to get the square root. Square root in the right and in the left, or in the left and in the right, I don't know. In the two sides of the equation, okay? So this in the end will be cancelled, okay? The square root with a 2 and the square root again with a 2 below. So you will have in the end 1 minus d, sorry, 1 minus d divided by d, and in the other side you will have the square root of 0.75 that I got 0.866. You can put 87, that would be okay too. Okay, now I need to leave d in just one side, okay? I just want to leave one d. So I'm going to move this d from the bottom. I'm going to move it to the other side. It is divided, it passes to multiply. So we have 1 minus d above because I didn't touch it. And in the other side I have 0.866 d. Okay? And now I want to move this d to the other side because I want d to be in one single side. Okay? So it is subtracting, and in the other side we'll be doing an addition. So 1 is going to be equal to 0.866 d plus d. Remember that when you don't see a number here, it's invisible one. So this is like having 1 equals to 1.866 d. These are like terms because d is the common factor in the two values. Okay, so it is a common factor. That means that you can add them or subtract them. If you want to see it in a different way, this could also be 0.866 plus 1. If you want to do it like that, it's also good. So this is equal to 1.866d, and this number here is a coefficient. That means that it's making a multiplication. So when you move it to the other side of the equation, we'll be doing a division. In other words, d alone is equal to 1 divided by 1.866. How much is this?
0.54.
0.54, because this is a distance, it's going to be in meters. But if you want to write the D in the left and the value in the right, you can also do it like this, and that will be just fine. And this will be the answer. But what does it represent? What does it represent? I know that it looks like a big process, but it's not too complex. So I'm taking my sketch again, and I will locate my charge in the position that I mentioned. Okay. So this is what I have. This is 1 meter. Now I know that D is 0.54. Okay. So I say D, which is equal to 0.54 meters, and 1 minus D is equal to 1 minus 0.54. So this is equal to 1 point, I mean 0.46 meters. Okay, so that means that my charge is more to the right than to the left. So I'm just going to arrange it to make it, for it to make sense. So basically, my charge is more to the all I did is analyzing the distances. This one is 0.54 meters, and 0.54 meters is greater than 0.46 meters. So I want that what I see in numbers makes sense in the sketch. Now this portion, this distance, looks bigger than this one from here, and now I say that it makes sense. Now is it necessary to do that? No, it is not. Okay, it is not, but I can put something here, and this other distance I can put 0.54 and here 0.46, like the definite answers. If you want to leave it like that, that will be okay too. Now analyze this procedure and tell me, is there something that you want me to explain again? Is there something that you want me to explain again? These exercises are not going to change too much. The process for making them is the same process. You can like it or not, but the process is going to be a little bit long, but easy. It's like in the superposition principle and about electric field. Long process, but easy. Okay, so you can start working here with B and C as part of the homework. And at least I'm gonna be here for 4 minutes if you have any doubts in the beginning. Now to make it more interesting for me, This one, Q1 is located at x equals 0 and Q2 is going to be located at x equals 1.5 meters. In C is Q1 x I located at x equals 0 and Q2 equals to x 2 meters. Okay, that is the only change that I will make for this problem for you. To make it more interesting. For you to do a different sketch, because if not, the sketch is going to be the same. It doesn't make sense if you do the same sketch. So when you write the word problem, you will put for the number 2, that is at 1.5 meters. And when you do the other problem, that's C, you will put here just 2 meters. That would be the difference. What do you think? Is this topic easy out of 10? Can you write it in the chat?
Miss, can you repeat, please?
How do you think is this topic in the level of difficulty out of 10? Is that 9 too complex that you find it very difficult? Okay, MC es por 10 a la menos 9 coulombs. Okay. Bueno, y dice cómo identifica las cargas si son positivas o negativas. El problema las da. Ok. Por ejemplo, aquí me da carga positiva 10, positivo 7.5. Mira, y aquí negativo 3.7, negativo 5.2. Ahora, el problema siempre le va a dar el mismo signo en las cargas. Like, if the charge is positive, le va a dar las dos positivas. Y la que tiene que encontrar es la que está en medio de las dos positivas. Si le da dos negativas, se tiene que encontrar la carga que está en medio de esas dos negativas y por ende va a ser positiva. Siempre la carga en medio va a ser opuesta en signo que la rodean. Like in here, esta es negativa, these two are positive. This topic is about